And you remember right where you were when Neil Armstrong and Buzz Aldrin landed on the moon. We got Admiral Ellis, we got Dr. Green, we got a few others. Bob over here, you were there. That's a big problem, friends. And we're going to remedy that problem. We're going back to the moon, and this time we're going to do it very differently than we even did it back then. This time we're actually going to stay. And we're going to create a permanent infrastructure that goes back and forth between the Earth and the moon for a very long time to come. And in order to do that, there's a number of things that have to happen, some of which we've already heard about from this very esteemed panel. So, when we think about going back to the moon, the first thing we have to do is think about what we're doing in low Earth orbit right now, what we've been doing for the last 18 years. Now, I know most people in here are older than 18. Maybe you're not old enough to remember the Apollo program, but if you're older than 18, you have lived most of your life with humans living and working in space. And that's been done in low Earth orbit. But that takes a lot of money, and if you look at the International Space Station, which has been a tremendous success, not just technologically, not just scientifically, but an amazing success internationally, bringing all these countries together under a treaty under which we can have these marvelous accomplishments. What an amazing success, but also what an amazing model for the future. Where we have to go in order to have people living in millions of people. Wow, that's quite a vision. And we want to get there too. And we want to do everything we can to make you successful and you make us successful. It's a wonderful partnership that we want to have with all of our commercial partners. But in this process, we have to think about how do we commercialize low Earth orbit so we can have millions of people living and working in space. How do you commercialize it? The idea that NASA has going forward is we want to be one customer of many customers. So we're doing that right now with commercial resupply to the International Space Station. And now we're going to move on to commercial crew to the International Space Station. So NASA, instead of purchasing, owning, and operating its own rockets, we are one customer of many customers in a robust commercial marketplace that is healthy. And to be healthy, we also need to have multiple providers that are competing against each other on cost and innovation. And so that's the market that we're developing in low Earth orbit for launch to the International Space Station, and eventually a commercial marketplace for habitation in low Earth orbit. So we need our friends at Blue Origin to be very successful with what their vision is. And ultimately, we need our friends at Lockheed Martin to be very successful as well. The reason we want commercialization of low Earth orbit is that NASA can then use its resources not to purchase, own, and operate rockets that can go back and forth to low Earth orbit, but we want to use our resources to go further. And when we think about what SLS is and what Orion is, the idea is we're going to the moon and we're going to build a sustainable architecture. We talk about what we've gotten from this competitive commercial marketplace in low Earth orbit. We're now seeing reusable rockets. Everybody in the world right now wants to figure out how to do reusability because the costs come down, the access goes up. We want reusability to not just be limited to launch to low Earth orbit. We want reusable tugs that go from Earth orbit up to lunar orbit. And we want a reusable command module in orbit around the moon. When I think about a reusable command module, think about a space station in orbit around the moon. Now, it wouldn't be like the International Space Station. It'll be something much smaller. It'll be in a near rectilinear halo orbit, which is quite a distance from the moon. But with solar electric propulsion, it will be able to go into very different orbits around the moon, enabling landers to reusably go back and forth between the gateway and the surface of the moon. This is the architecture. It requires for sustainability, which is what the President has charged me with Space Policy Directive 1, to go to the moon sustainably, we're going to need reusability. It's also important to note that in order to achieve this, we're going to need commercial and international partners. This is not the United States going it alone at all. This is an international collaboration for an architecture that is going to be open. So the way we do data, and the way we do power, the way we do avionics, the way we do communications and docking, all of these things need to be open architecture. So if there's a commercial company out there that wants to go to the moon for some reason, they can take advantage of the architecture that we're building. If there's a country in the world that wants to do something on the moon, they can take advantage of the architecture that we're building. If they need that reusable command module, which is the gateway, because they want to build their own lander, we want them to have access to that reusable command module. The idea being open architecture so that everybody can participate, include everybody, and it's not just countries that can build landers, it's private companies that can build landers, and countries and private companies can build tugs. The idea being that we're going to make it sustainable. Ultimately, what we want to do is retire the risk, and prove the technologies, prove the capabilities, prove the markets, prove the human physiology, and then take all of that and replicate it at Mars. As much of it that can be replicated at Mars, and not all of it can, but as much of it that can be replicated, that's what we want to be able to do. The goal is to get to Mars. The first gateway, which I said would be that reusable command module in orbit around the moon, the first gateway would be at the moon. It would be a technology demonstration. It would be a proof of concept. The second gateway, we could do one in the future that would, no kidding, be a deep space transport and could very well be ultimately the vessel that takes humans to Mars. So here's the thing. The folks in this room that weren't alive, by the way, I wasn't there either. I was born in 1975. I was years after the first moon landing and 3 years after the last moon landing. I wasn't there either. But it's your generation that needs to reestablish that moment when the folks who come after you have that moment maybe when they're 8 years old, and they could maybe even see somebody in this room land on the surface of the moon, and they would be inspired by you just as previous generations were inspired by Neil Armstrong and Buzz Aldrin. So that's what this is all about. If we're going to be successful achieving 1 million people living and working in space, if we're going to be successful in achieving that, we're going to need everybody in this room to be successful. And everybody that comes after you to be successful. So that comes down to inspiration. And of course, we've had those moments in history where we've all been inspired. And we want to recreate those moments for generations to come so that we can achieve that objective of millions of people living and working in space someday in the future. So I just want to say thank you. I'm happy to answer any questions, and it's an honor to be here.
So I already got some questions here for all of our panelists. So I would welcome if I will address it as one of the panelists.